Hello friends and welcome at my channel. Today I would like to show you how to compute some inverse function to given functions. So first of all I have to say normally we have to make sure that those inverse function exist. We do it at university if we are working with injective, surjective and bijective functions. Well, you should make sure you got some ideas about that. And once you figure out the function is bijective, that means that it really should have an inverse function and you should be able to compute it. So I just show you how to compute it if you know that the function already is bijective. So y is equal, for example, to 3x plus 4. So how can we compute the inverse function to this? Well, you see, this is the graph of 3x plus 4. It looks like this. This is 4 and the slope is equal to 3. And so what the inversion function is actually doing is we are rearranging the x and the y values. So I just have to solve it for x. Y minus 4 equals to 3x. I'm dividing it by 3, minus 4 first. And then I have x equals to a third of y minus 4 thirds. So the inverse in this case would be a third of x minus 4 thirds. And maybe you know it, maybe you don't. Uh, I proved it in my other channel in German language that the function should be um, reflected on the um, y equals to x identity function. I just link it here and you can check it also. It's only in German, but the mathematics behind it should be clear. So the inverse function is really reflected and it would be looking like this. So it's no coincidence. There is a reasoning why. All right, that's the first step. The second one, well, let's see, we have y equals to x squared minus 1. And you see, if we're talking about the inverse function, well, a function should be a combination of x and y values such that to every x we get exactly one y value. See, so this is a parabola. And, well, we cannot make a function with the whole parabola, so we have to kind of cut it off. So we are only reflecting this one. That means we're still solving for x. So x squared is y plus 1. We're having x, it would be plus minus square root of 1 plus y, but we prefer the positive and not the negative because we are not reflecting the left-hand side, this part. So f to the power of minus 1 of x is exactly square root of 1 plus x. This is what I was talking about bijectivity of functions. If we would be taking this function from R to R, from real numbers to real numbers, it wouldn't be bijective. Make sure you understand this concept. And well, the next one is, let's say we have y equals to cubic root out of 1 minus x to the power of 3. So, well, first of all, we can take all kinds of odd roots out of positive and negative numbers at the same time, even at school mathematics, at high school mathematics, so it's no problem. And, well, we have to solve it for x again. So take it to the power of 3. You have 1 minus x cubed. Then we just bring x to the left-hand side and y to the right-hand side. So x cubed is equal to 1 minus y cubed, and then take a cubic root. And now we see a very interesting situation. X is a cubic root out of 1 minus y cubed. So that means we have f to the power of minus 1 of x, which is a cubic root out of 1 minus x cubed. So this is the function itself, which is really nice. We have also f of x equals to x equals to f to the power of minus 1 of x, so inverse function, and we also have f of x equals to 1 divided by x equals to f to the power of minus 1. You see that? Why is that the case? Well, once again, if y is equal to 1 divided by x, we have to solve it for x. That means x is 1 divided by y. That's why if f of x is 1 divided by x, that means f to the power of minus 1 of x is 1 divided by x as well. Really nice. And the last one for tonight is if we have y equals to a logarithm of x divided by 5. Let's say this is the power of e, so ln, basically ln of x divided by 5. Once again, we have to solve for x, so we claim e to the power of y is equal to x divided by 5. We multiply times 5, and x would be 5 e to the power of y. So f to the power of minus 1 in this case would be 5 times e to the power of x. All right? I hope it makes sense. Make sure you understand concepts of injective, surjective, and bijective. And if you have any questions, let me know in the comments. Thanks for watching. See you in the next video. Bye-bye.